Thanks for the intro. Thanks everyone for joining today. I'm Asif Waquar. I'm a solution architect at Munich, Singapore. And today I'll be presenting about the building AI-driven real-time Lakehouse API. So, how many of you, I believe everyone knows about the iPhone. How many of you know about BlackBerry? Yeah, and the reason why the BlackBerry failed. Yeah, so the key idea is we all know BlackBerry was one of the premium phone in early days, and then later on the iPhone came and it took over the market, right? So I was yesterday here and listening the sessions and a lot of AI buzz and topics, and but some of the sessions also notified that AI cannot do everything because of the different. We need to also consider the data quality, because if garbage goes in, garbage goes out, and that's the key problem. Means AI cannot build everything for that. Yes, definitely true, but we also need to consider that. If we are thinking, if we should not miss the boat, right? Because we need to understand how the trend is going on, and we need to understand how the market is evolving, and accordingly we need to upgrade ourselves, and that's the key message. So because if you think about these companies, right, BlackBerry, Nokia, Yahoo, all these companies failed because they could not adopt the change, and that was the problem. So in today's session, this session is about how we can build a real-time data lake APIs. Basically, you want to have a real-time data which is coming from the different sources, and how you can open the data APIs and can use some of the AI capabilities to understand the data more better, and rather than having your standard Power BI reporting, which is So imagine you get up some morning and you find out that there is a loss of $100,000, right? And there was a fraud happened, and the alert came later. So that's the world we were there, because that we were having a batch process which used to run every day and not real-time APIs. So yeah, and the second could be, let's say, if you are using some shopping cart websites and you are seeing the product which is yesterday's product, and the similar could be like these are the use cases that when we are seeing the problem, have a real-time data. Sorry. Yep. Okay. So imagine what will happen. So how we can flip this story, because this is something, the real problem. Because currently, in today's session, what I'm going to share is what we were working on, some of the big data capabilities and the solutions, which were having a real problem, because we used to have a everyday batch run, and early in the morning, 9 a.m. and some of the batch run used to fail, and we have issues coming from the different departments. They were complaining, okay, our report is not ready and the data quality is not good. And so how many of you were facing such issues till today? Yeah, so I think that's the key problem we are trying to solve, and with the help of some of the latest technology and tool like Lakehouse. So I will explain what is Lakehouse, and yeah. So let's see how we can use this, to real-time AI-powered Lakehouse APIs. So let's go back into the history of how we started. We started with the ETL process, where in 2000 we have our apps, which is coming from the different databases, and then we used to have a batch process which used to run every night. And then we have a data ready in the morning, and we used to consume the data with the Power BI reports or BI intelligence tools. Then in late 2020, then the Lakehouse came. So Lakehouse given a more better approach in terms of storing the data and then providing the insights to real-time data of structured and non-structured both. And then the late Databricks came with a new concept called Lakehouse. The idea for the Lakehouse was to build a platform where all the data can be stored in a lake and that can be queried. It was cheap and it was a better solution in terms of querying the data of structured, non-structured data. And that's where we are now in building a Lakehouse. So how Lakehouse can solve our problem from batch processing to the real-time APIs, right? Okay, how many of you know Databricks and working with the Databricks? Yeah, so Databricks, it's a very powerful tool, and it provides, it works on top of the Lakehouse, and it provides a capability to have support multiple formats of the files. That's called Delta Lake, Parquet format, or CSV. So it supports all type of files, and it have a governance model that's called Unity Catalog. And there are some specific pillars for the Lakehouse with the help of Databricks, which is the data governance interoperability, because it can integrate with the different tools, databases, files, and SAP. It can integrate with the different tools. And that's where, so most of the organization which were using Lakehouse, so now 75% of organizations globally, 74%, sorry, is changed or adopted already the Databricks. So they are quite comfortable in processing the data in structured data and non-structured data at the real time or the real time basis, right? So, but Lakehouse, it comes with the Lakehouse comes with the capabilities of, it was developed separately, considering only the Lakehouse, considering the data of processing for structured and non-structured data, but it doesn't consider the AI capabilities during the time. And that was the gap between the whole process of having the Lakehouse and the AI ML ops. And if you can see, that's a reason most of the AI products fails, because they do not understand what type of data we are bringing in. And that's the key problem which we have in the current systems, which is we don't know the data, and then we are building AI solutions on top of it. So how it will be success? And that's where what we are looking is AI Lakehouse architecture, which is more on how we can build AI capabilities on top of Lakehouse. So basically, the idea here is to open APIs or to open for structured and non-structured data in real time, and then use AI capabilities on top of it to make it more better in terms of visualizing the data. So if you see in this, currently we have a source system, and the data is orchestrated with the help of Data Factory, which goes into a different layer that's called a Mendelian architecture. So where when we have data, structured and non-structured data lands to a bronze layer. So basically it's a raw data, and then we have a silver layer, which is a form of when we perform some validation checks and improve the data quality, that goes to a silver layer. And you might be wondering that why I have kept the gold layer in the Lakehouse gold layer in a different block, right? Usually it is in the same block. With the help of Databricks cluster, we'll have the final gold layer of the data. But what I'm going to show today is the capability with one of the tool called Microsoft Fabric and the Databricks integration, and how it can help to improve the overall experience in terms of building the data APIs and data pipelines, which can provide a more better insights in terms of, and more better governance in terms of, although it's from the Databricks, this is not approved the solution. However, it depends on your use case, how you want to improve your data quality and ensure your governance model. Because let's say if Fabric comes with a more better security and governance model. And if we keep the gold layer in Microsoft Fabric, it provides a more flexibility. And let's say it also, because Microsoft Fabric have provided an integration with the Databricks recently, last year. And that's where, let's say, if previously what used to happen is, if you are trying to integrate with your Microsoft Fabric or data lake with Databricks, so or any other solutions where you have like Power BI, where you have to expose the report. So the data needs to copy it from the gold layer to for the reporting or BI analysis purpose. However, with the Lakehouse, it was more on, you can create, because in the Lakehouse we have a concept called shortcuts. And what you can do is you can virtualize the table from the layers to query the data. Means you can still keep the gold layer in Databricks, and you can query the data with the help of virtual tables. However, it may be an issue in terms of latency and performance, and that's where if we keep the gold layer into the one lake premises, it will be more better in terms of the performance and more better in terms of the security. That's where I have kept this layer into the Fabric environment. So how we can build, the data lake APIs, data APIs. Data lake itself will not give you everything. It will give you more better in terms of performance. It will give you more better in terms of storage. But as I earlier mentioned, that let's say if you have to build a AI lake architecture, and if you want to provide, if you want to query the data with the help of LLM models on your own data, then you have to build the AI capabilities on top of that. So the way to here is, let's say if we keep the data in our data lake house, so what we can do is we can open an APIs with the help of Microsoft Fabric. There is an option to open APIs with the help of Workspace. So you can see here. So what I'm doing here is I'm trying to create a lake house, a new lake house in Microsoft Fabric with the help of APIs. And similar way, you can query the data from Microsoft Fabric gold layer, or you can perform any queries on top of it. And this could be also integrated with your open APIs or Azure AI Foundry or your own LLM models to build a RAG and then query the data. So this is how I am creating, because Microsoft Fabric, what it provides is, it also provides a Databricks kind of a notebook, and you can perform a query on top of it. So you can call the APIs from here, or you can call the APIs directly from your external applications, whichever you prefer. This is for only just for the demo, which I have given the reference here. And so basically the idea here is, if we are using a real-time APIs, let's say previously we used to get the alert, which was a batch process. It used to take a time, but with the help of APIs, it's giving alerts which is faster compared to the previous. And that's how it's giving the capability to solve the problem, right? So if you can see in the architecture, we have the Fabric one lake, and then we have different tools like AI search. And so I will just go one by one. So first icon is data agent. So basically what you can do is, inside Microsoft Fabric, they provide a flexibility called building a data agent. So basically what you can do is you can query the data on top of your lakehouse with the help of data agents. The second option could be that in Databricks itself, let's say if you want to query the data of silver layer, or if you want to perform some checks on the silver layer, so you can use, even though that's called Databricks Genie, and that's the inbuilt capability of Databricks Mosaic AI, and they gives you flexibility to query the data with the help of Genie, and that's really helpful. And what we have done recently is we had a document store our storage space on OneLake, and those documents was a PDF and different types of document. And this was one of the use case which we were working from previously. And the data was also, because I comes from a reinsurance background, and where we have a big contracts, the treaty, and those documents was stored in SharePoint. Some of them were in storage. And we have also treaty related informations like claims and premium checks, which was in the database. And that's where we have taken the data lake as a source. We build the RAG on top of it with the help of Azure AI Search. And so basically, Azure AI Search, what it does is it performs the indexing on your data sources. Like, let's say it could be a data lake, it could be a SharePoint, it could be a storage. And then we build the agents with the help of Azure AI Foundry or Azure OpenAI to call the data, to talk to the data. And that was the use case which we have recently built. And that you can do with the help of OpenAI or Azure AI Foundry, or you can do with the data agent within itself. And this can be exposed via the APIs. Yeah, so this is the Jenny example which I was explaining for the Databricks. So if you can see, you can query the data with the help of Jenny and in Databricks cluster notebook. And then you can build the visualization on top of it to understand your data more better. It could be silver layer or gold layer, however you perform your, And another example which I was explaining about the Fabric data agent. So this could query your Lakehouse data, which was the gold layer, and you can perform the queries with the help of Fabric data agent. And yeah, so this is in the gold layer. And Fabric data, and the third example which I have explained about that how we are performing the search on the different data sets, and in terms of lake, or either stored in the SharePoint or stored in Azure storage. So if you can see, Azure AI Search gives us a flexibility to have integration with the Azure AI Fabric, Azure AI, SharePoint, all this. So we can build a RAG on top of it, and then we can query with the help of the data agent in Azure Data Lake. Yeah. So closing. So let's say if you are building solutions for the real time, so always try to make it real-time Lakehouse. It will give you more flexibility, and then you can power with the AI, and we can have integration with the APIs. You can integrate the different apps, and that's where we are trying to solve the problem with. Yeah. So, any questions?
Questions? No, I thought it was a question. So what's the main difference between the, let's say, old data lake idea, where you put everything, anonymize whatever to make it available for the business, and I remember some CIOs incentivized by the size of the data lake, right? So can you imagine when your bonus is tied to the size of the lake, right?
Yep.
So it can be extremely huge, and that the goal was to make everything, right? Versus the Lakehouse idea.
So the data lake was
can you speak in a microphone?
So the data lake was more on how we are building with the structured and non-structured data. And with the AI Lakehouse, what we are trying to build a capability on the AI capability to query your data. So let's say, as I explained in my earlier the diagrams there, that we have data sitting in the gold layer, and we want to query the data. We want to talk to the data. Let's say, give me the example of what the use case which we are building is. Let's say, for example, we have treaty documents which is stored in SharePoint and the Azure storage. And then we have some data which is relevant to the treaty. What was terms and conditions discussed? What was the premium price? Or the claims was, if there is any claims related to it, and that data is stored in SQL or in some other format. So how we want to compare the data and get the output? Is it relevant to that, and get the better results? So AI Lakehouse gives the more flexibility in terms of having a standard Power BI report to your what you are looking into that. So okay. You don't need to search the whole SharePoint or database, and that gives you the more flexibility there.
Okay. Yeah, you have a question.
So when you talk to the data in a Lakehouse, how do you ensure the accuracy?
Okay, I think that's a very good point, because in terms of accuracy, we are building the RAG model. And the RAG model, as I earlier explained, this was one of the key things, because initially we were performing the search directly with the LLM, but the data was not very accurate. To ensure the accuracy, we built the RAG model on top of it with the data lake and with the SharePoint and the different models, and then we query the data with the RAG, and then we get the better output. So yeah.
We have time for a last question here.
Question about the data lakehouse. When you building a platform with multi-tenant database, and what is your recommended strategy for scale when you have multi-tenant database data, and you want to enable some kind of AI but not get context too much crossed? Second question is regarding the security authorization. When you're working for the enterprise, when you have a layered hierarchy data, how you ensure the role level security will be implemented along with the AI together as well?
Okay, so I would split in this two parts. Like one is first how we are processing the data, how we are distributing our data into different Mendelian architecture, right? So as I shown in one of my architecture, if you see, I have kept the two layers, the silver and the bronze layer into the Databricks cluster to perform, and then the final layer was in the data one Lakehouse. The reason why it provides more better in terms of the governance and security, because you can have a separate workspaces, and you can have for the, let's say if you are using a multi-tenant database, so what you can do is you can build a different pipelines to move the data into final gold layer to the one lake, and there you can define your security permissions and the groups, how you want to distribute the data and query the data from only for a specific because the workspace gives you the flexibility that you can choose the tables, you can choose the databases, which users you want to give the permissions to give the access to the data, and that's where so you can have a more granular in terms of the security, the row level security architecture based on your how you define your layers architecture. So that's because although there are pros and cons to it, because let's say if you move all your data to one lake, this could be that you will get better in performance and better in terms of security, but your data will be in the different environment. So
thank you very much. Thank you.
Thank you.